Hello YouTube, Ethan here. Today I'm bringing you a very practical, short video on matrix addition and matrix multiplication. In today's video, I'll be demonstrating how we can perform these operations and when we can perform these operations. If you find this video helpful and want more content, please hit that thumbs up button and subscribe. First, let's define what a matrix is. Simply put, a matrix is a rectangular arrangement of elements accounted for by its rows and columns. Here's one example of what a matrix looks like. Take this matrix A and let it equal 1, 2, 3, 4, 5, 6. Matrices are described by their rows horizontally and then their columns. The size of a matrix, often denoted by m by n, is defined as its number of rows times its number of columns. Also, for purposes of reading this notation out loud, the x is always read by. Kind of like 2 by 4, which is common dimensions for wood. Our example matrix here has 2 rows and 3 columns. So we would define this matrix's size as 2 by 3. Now let's take a look at matrix addition. Firstly, matrix addition is only defined for matrices of the same size. When adding matrices, simply sum each element in the same position. Here's a quick example. Say we have 2 matrices A and B such that A is equal to 1, 2, 3, 4, and B is equal to 5, 6, 7, 8. Let's say that we want to find a matrix C such that it's equal to A plus B. Then, observe that matrix addition is defined because both matrix A and matrix B are 2 by 2. Let's go ahead and add these, which is pretty intuitive after seeing it once. A plus B is equal to the matrix 1, 2, 3, 4 plus the matrix 5, 6, 7, 8, which is equal to 1 plus 5 in our first position, 2 plus 6 in our second position, 3 plus 7 in our third position, and 4 plus 8 in our last position, which is equal to 6, 8, 10, 12. And that's how you find C. Subtraction works similarly, except instead of adding these two numbers, you would just subtract. Before we look at matrix multiplication, let me show you what happens when a matrix is multiplied by a scalar. Scalar multiplication is defined between any scalar and matrix combination. When multiplying a matrix by a scalar, each element of that matrix is simply multiplied by the scalar. Let's look at a quick example. Let A be a matrix defined as, once again, 1, 2, 3, 4. Say we want to find 2A. This could be done by writing 2 times the matrix A, which is equal to the matrix of 2 times 1, 2 times 2, 2 times 3, and lastly 2 times 4, which comes out to be 2, 4, 6, 8. This means that if every element of a matrix shares a common factor, we can factor that out as a scalar. For example, take a matrix B, which is equal to 3, 6, 9, 12. Then we could factor a 3 out of B, giving us 3 times 1, 2, 3, 4, which is equivalent to 3A from our previous examples. Now let's move on to matrix multiplication. Matrix multiplication is defined when two matrices have complementary size. This is best illustrated through examples. Here are two matrices which can be multiplied together. The matrix 1, 2, 3, 4, 5, 6, and the matrix 1, 2, 3. Observe the different sizes of each matrix. The first matrix is a 2 by 3, given that it has 2 rows and 3 columns. And the second matrix is a 3 by 1, given that it has 3 rows and 1 column. Because these two numbers correspond, matrix multiplication holds, and the resulting matrix will be a 2 by 1, given by these outer numbers. So this will equal some matrix that is a 2 by 1. Here are two matrices for which matrix multiplication is not defined. The matrix 1, 2, 3, 4, and the matrix 1, 2, 3, 4, 5, 6. Looking at the sizes, we have a 2 by 2, and then we have a 3 by 2. These inner numbers don't match, so then these two matrices do not have complementary sizes. It's also important to note that when matrix multiplication is defined for two matrices, A and B, A times B does not necessarily equal B times A. In fact, this can even break the multiplication. Now to perform multiplication, we're going to dot A's rows by B's columns. Once again, this is more easily demonstrated by examples, so let's get into one. Let's take the example of a matrix A defined as 1, 2, 3, 4, and a matrix B defined as 1, 2. To multiply these two together, we're first going to take the first row of A and multiply it by the first column of B. That's going to give us 1 times 1 plus 2 times 2. This is what we mean when we say we're going to dot the rows of A by the columns of B. Next, we're going to take the second row and perform the same operation as we did for the first row. 3 times 1 plus 4 times 2. Calculating, this will give us a 2 by 1 matrix equal to 5, 11. And it's as simple as that. I'll do one more example just so y'all can see it done again. Here's a more involved example. Let's say we want to find a matrix E such that E is equal to 2A times B plus C times D. Let's go ahead and define our four matrices as A equal to 1, 1, 1, 1, B equal to 2, 2, 2, 2, C equal to 3, 3, 3, 3, and D equal to 4, 4, 4, 4. Notice here that matrix multiplication and matrix addition are going to be defined for all operations that we conduct because all of these matrices are the exact same size, 2 by 2. So let's take it step by step. E is equal to 2 times the matrix A multiplied by the matrix B plus the matrix C times the matrix D. First, using our rules for scalar multiplication, we're going to get that 2A is just equal to 2 distributed to all elements of A. Now, using our rules of matrix multiplication, we'll find So we get 2 times 2 plus 2 times 2 in each of our 4 spots for our new matrix. And then for everything to the right-hand side of our addition sign, let's go ahead and calculate that. We're going to get 3 times 4 plus 3 times 4 in every position on this matrix. Let me just go ahead and finish filling that out for y'all. All right, and I'm going to move the screen down a little so that we have more space to work. All right, there we go. For further computing, we're going to get this to be 2 matrices. The first one is a 2 by 2 of all 8s, and the second one is going to also be a 2 by 2 of all 24s. Okay. Then finally, we use our rules of addition, and we're going to get in every single space 8 plus 24, which, if you're working ahead, you'll see is just a 2 by 2 matrix of all 32s. Okay, we know from earlier that this could actually just be rewritten as 32 times 1, 1, 1. And there we have it. If you made it to the end of the video, thank you for watching. Stay tuned for more linear algebra tutorials in the near future, and if you found this video helpful, please like and subscribe. Thanks again for watching, and put in the comments below any video suggestions, requests, any potentially tricky or sticky homework problems that would be fun to run through on these videos. Thank you.